the class. So the first thing I mentioned, if you have not done so, go to USACO's website, create an account. For each account, once you log in, those even though the contest right now is not active, right, will become active in, I think, in November, right? So, but those are problem in the past, like the one that we have been doing in our homework. You can, once you log in, you will see those buttons. If you don't log in, you don't see those buttons. So make sure that you log in first. And then for each problem, you will able to select a C++, and then choose a file, and then you pop up. Then you can upload your file and then submit the solution. And then you will go through those 10 test cases on the top like that. You go through each of them. If you see the star on each test cases, then that means it passed. If you see an X, that means that it failed on the test cases. So that's the way to verify your answer for each problem, right? This is the nice way they can still score, even though those are the past content. So this is the one that for those that are still on the USACO.org, those are past exam. And then the training one, the online training, so those are even older when they put it on the training. And they do not share the same account. So if you have set up one on the training side, and you cannot use that same account to log in here, you need to create this one separately. Okay. So with that, let's look at our homework first. So last week's homework, so the topic we discussed last week is about simulation. So it's not necessarily simulate the actual simulation, but rather you go through some of those scenario. You just doing a loop to carry all the scenario and then evaluate the outcome, right? For this mixing milk problem, it is just like it said they need to have 3 buckets. They need to pour milk from one bucket to another bucket. Right? You do that for 5,000 operations, I believe. Is it somewhere? For total 100 pour operation, 100. Oh, so this is for 100 pour operations, right? So it is from one bucket you pour the milk to fill the bucket that you pour to until it's full, then you have to stop. Or the bucket that you try to dump it, if it's empty, then you have to stop as well. Right? Either way, then you have to stop. Each time that's one operation. You do that 100 times, then you're asking you what are the amount of milk remaining on each bucket, in each bucket. So just do the. So you just doing a loop for the 100 pour simulation. So this problem shouldn't be too complicated. So you just have the input read. So you have each bucket. So you need to keep track 2 numbers. All right, each bucket has capacity and milk amount. And then you perform this 100 pouring operations, which from bucket A to bucket B, and you just need to calculate the amount of milk that you can pour from A to B, and then update, subtract amount from A, and add amount to B. Just to do this 100 times. So one way a variety of ways to do this data structure, right? We can do this capacity and milk 2 separate vectors of 3 elements. So we define this N as 3. So using a variable rather than putting the hard coding 3 here, so that this code, next time you're doing with a 4 bucket, you just change it as a 4. So that's generally when you need to have some hard coding number, trying to replace the hard coding number with a variable. And then this operations as well, we put this number operation so that you need to go through. And so 3 buckets define 3 buckets of capacity, 3 buckets of milk amount, and then you use the 3 temporary variable. One is this is a bucket that you pull from, and then there's a bucket you pull to, so that using this as an index for keep track those 3 buckets that are in the milk, right? So you first read the input, those 3, right? 3 buckets capacity, 3 buckets of milk or initial milk amount. Then you do this 100 times operation, reading the loop. Right? So the first thing you need to figure out which bucket you need to pull from, which bucket you pull to, right? So that's based on this operation index. You just do a modulo 3, right? And it's doing that as a 3, that it go from 0, 1, and 2, right? That's the bucket index for those 3 buckets. So you're getting those bucket index, and then you calculate the amount that you can pour, right? The first you need to be minimum the bucket that you can pour from, and then the difference in their capacity, right? This is the bucket you pour to, that's the capacity, and then subtract the amounts already there, right? That's the remaining capacity you can pour. Just do a minimum of the 2, that's the amount you can pour. Then you update the milk amount on the bucket you pour from, and then update the bucket that you pour to. So do this 100 times, then you output this milk vector. So any question on this first homework? This should be very straightforward. In terms of efficiency, there is no way to get around this. I guess probably you can find out some repetition pattern after a while, then you can calculate and you don't have to go through 100 times, but then you need to find out the pattern. And the only thing is to just have 2 vectors to keep track of capacity and the milk, as well as having this modular, the index to keep track which operation on which bucket. Okay, the second problem, so it is a little complicated compared to the first problem. Now you need to deal with 2-dimensional arrays, right? So there are the rows and columns. Each row, they want you to do the scale, the factor, the scale, whatever. This is a number, right? The last number is the scale. If it's 2, that means each element will be repeated twice, as well as the row will be repeated twice. Like this, a row will be repeated twice, the column will be repeated twice. If it is 3, you do that 3 times. So this last number is the scale. So you just need to do the scale on both the column and the rows. And so once you figure out that's what it's asking, right? So just for each of the rows, you scale each element k times. So you first read this n by n matrix. So it's a 2-dimensional matrix, and then you just read through this matrix. For each row, you scale the column, then you scale the row. So you can do the two ways. One is the original matrix, and then you build the one that scale the matrix and then output it. Right. That's or you don't have to store the output the matrix since everything is just outputted to a file, right? So you read the input file, reading those three integer number, then you read the input into this 3D matrix. Okay. So since each it is a character, so I'm using the two-dimensional character as this data structure. You can also do a one-dimensional vector of a string, right? Each row, you treat each row as a string, and then just have each row then append or push back to that vector. So you can do that as well. Then you just go through this two loop, two dimensions, right? In the row and the column, right? In the column, you just and then do a loop on the scale. So for each element, you just duplicate the element how many times, right? Have another loop duplicate. So unfortunately, C++ doesn't have a multiplication. So for those of you who have learned Python, for Python, if you want to scale it, you just have this character, right, multiplied by k. That will repeat k times just in one line. Unfortunately, I guess you can write a function to the multiplication, right? Repeat that how many times you can write a function to do that so that you don't have to go through this loop. This is most easiest to just repeat this at k times, right? That's added to, you start with an empty string, this row, and for each element, you repeat it k times, right? And then when you're done with this row, then you output it k times. So let's duplicate the output. So we will look at the actual code. So this problem is not that complicated, right? Just a four nested loop, right? You have a row and column and then a scale. And then for each row, then you put a scale. Right? Okay, the last problem probably is a little more complicated. So it's basically to keep track of the speed, the limits on segment of the road, and then let's see, the cow driving the tractors, what's the speed how fast she is going on each segment. That So those segments, they are not necessarily in sync, right? The changing speed is not necessarily on the boundary of the speed limits boundary. So um, so there is a multiple, since the boundaries they are different, right? So if you look at this problem, you first reading those two numbers and m. Right. So it is saying that has the first n is the speed limit, and then the next m numbers and rows the battery's speed. So you can look at the row, right? So from the mile marker, from the 0 to 100 mile, then right. So if the speed limit, or whatever it is, right? So this is and this is 1, 2, whatever. How many segments being separated, and then that's is a so 1, 2, and then 2 the m segment. Right. Since those two segments they are not in sync, right? So one easiest way just build up the entire 100 mile with the speed limits, and then fill up 100 miles with battery's speed, and then just compare each mile's marker. So that's probably the brute force solution, right? You in order to avoid checking the segment, the overlap between the segment that is driving versus the speed limit segment. So you can just fill up the each mile, checking each mile's the speed limit, and then checking that each mile's speed, and then find out what's the maximum speeding that she travel along the 100 miles road. So that's one way. Right? So if you look at this check every mile, so you first building this two arrays, right? Both with 100 miles. The marker. So using this from 0 to 100 mile as a marker of the speed limit and basis speed, and compare these two, right? So just loop it 100 times. So in terms of the logic, this is probably very simple, right? You just read it, set the speed limit, right? So the speed limit, and then giving the range, right? It's reading the start value for each of those and number line, you're reading the length. So you start from the 0, the first marker starting at 0, then to the next length segment, and that's the end marker. So you start from the start till the end. Those are miles marker between them. You set the speed limits, right? And then you set the next segments start as the end of this segment, right? So then you go through this end time that will set the speed limit to those 100 miles markers. Right? You do the same thing for battery's speed. Right? You start with 0 miles marker, and the length, the travel, the segment, that's the ending marker. And then between the start and end, you do this loop between the start and end for each mile. You set the speed, and then you set the start to the end for the next segment. And once you've done that for 100 miles marker on the road, then you go through this 100 miles, sorry, length is 100. And then you just check the speeding, see whether that is the speed, subtract the speed limit. And you start with the max speeding, right? We start max speeding is 0, right? Start with the max speeding is 0, then for each mile marker, you check this speeding, and if it is this speeding is greater than the max, you set the max to speeding. So this is, even though not very efficient, but it works, right? So this is go through the 100-mile markers and check the speed limit and check the battery speed. So this will avoid line up those overlapping segments, right? But we want to reduce those loop to 100 miles as markers to check 100 element loop, right? So one way to do that is just check the. So actually, this is second one. So we read the first solution, right? We read the speed limit and then read battery speed. Then we check the speeding. Well, at least we still using this 100-mile markers or the 100. Then, but in the same time, when we read battery's speeding, this traveling speed, we don't have to. Store that. We just check, right? When you read each speed segment, just compare with the speed limit and then calculate the speeding. So this is the speed within this start and end, right? Within this start and end. That's the speed we read it from the input. Then just directly calculate the speeding and then calculate the max speeding. And then when we are done with this, then we are done with this max speeding, right? So compared to the first one, we said this speed, right? There is really no need to store this vector, right? There is no need to store the vector. Just go through this loop, check the speeding, and then we don't need to store that speed. So that a little better, right? So that at least we get rid of the vector that's saving battery's speed, right? We don't have to, we don't need to use this 100 elements vector, and we save a loop, right? So this another 100 element loop. So this first solution do that 3 times the 100 element loop. Right? The second solution only do the 2 times. Okay, so that's still not very efficient. So I'm going to show you one that actually doing the right way, right? So one way to to keep track the segment, we can use a map data structure, right? A map data structure for the speed limits. What's the start? What's the end? The start and end segment that will track the range of the road, the start and end. Put the start and end as a pair as our key, and then this integer is the speed limit. So we can use this speed limit as a map. Okay, so we first build this speed limit map. So just like that, before we have a start at 0, that's the first one, where we're reading the length, and then the start plus the length is the end, right? And then remember this, put the 2 variable into a braces, and it become a pair. You put this in a pair as a key, put this key as an index to this map, and then you set the speed. You put a start and end as a pair, you put in the braces, that's our key. That's for the speed limit, start and end, and then there's the speed. So that's probably the most efficient way to build this data structure for the speed limit, right? So once we have this, right, just like solution 2, we don't have to store that is speed. We just need to go through each road segment she traveled and then how fast she traveled and calculate compared to the speed. Right. So then this is the second part, we just read that is the speed and then check whether it's over the speed limit or not. Right. We read each segment, the length, and then the speed start with 0, right? And the end is a star plus the length. Then we need to get the speed limits. But now, given the start and end, we need to read this speed limit, whether this segment overlapping with any of the speed limits range. So we need to go through each segment of the speed limit. So this is the loop goes through the speed limits segment. And then this is the key, like we use a range, and this is a key, and that's the speed limit, right? So we use an auto, and then adding the const is just decorated those two variables. They are constant variable. We just getting the key and the value from this map that we don't want to modify. So you're adding this constant declaration so that just in case any code later on you're trying to modify those two variables value, it's going to compiler going to catch it, give you error, right? So we use the ampersand so that you're getting the address of the key and the value, put that into this range and limit. So and that's how in C++ getting the key and value, put that into a bracket, right? This is a key and value from the map. And then the range, remember range that we're getting the key, it is a pair. So pair has a dot first and dot second. Remember, right? We went through the pair data structure, have a dot first and dot second. So that's how you get the first element, the second element, which is with the start and end, right? We're checking see whether this speed limits segment, it is identical to Betsy's travel segment. Start and end is the Betsy's travel segment versus the range the first or range the second is the speed limits segment. We check whether they are identical, then we want to calculate the speeding. That is just a Betsy speed subtract the limit. Or we want to track whether there is any overlapping, right? So if Betsy's start of the travel is after this speed limits start, but then it's less than the end of the speed limit. So that means Betsy is traveling within this speed limit zone, right? So this star is inside that speed limit zone, or whether this ending also in the speed limit zone, right? So that's a so we have to check there could be another condition. It could be that the speed limit zone, the starting is within this range of the Betsy's start and end as well. So the speed limit start between the Betsy travels start and end, and then the speed limit ending within the travel and end. So we just need to check all of those 5 scenarios. If it is, that means those two segments, they are overlapping. Whenever they are overlapping, then we can calculate the speeding, right? That's the speed, that's the speed limit. And then we check this the same as before, whether this is speeding, it is greater than the max or not. Right? So if this speed is under speed limit is negative, it doesn't matter, right? We compare with 0, even though it's travel under the speed limit, this logic still work, right? This speeding doesn't mean it has to be over the speed limit. Even if it's travel under the speed limit, the whole logic still work, right? We compare this max speed, meaning we start with 0. If it's a negative, this should never be true, right? See, we just need to go through all the speed limit zone for each of the segment that basically travel, just go through the zone. So the data structure is, I think, the critical for getting this right, using a map and a pair. Right? You can put another map as your key, right? Just a map of a 2 integer, which is pair is the standard, a special case of a map with 2 elements, right? And then the nice thing about the pair, you can use in dot first and dot second. Versus if you do a map for the key, another map inside it, you cannot dot first or dot second anymore. Yeah, you have to use the index, right? To use 0 and 1 index. Okay. Any question on this solution? So this probably you have not seen this looping through the map before, right? So using an auto so that you're putting the variable in the key and the value on the map and treat it as auto, right? This is, and then the key then is automatically based on is defined as a pair, and then the value is an integer, so that the limit is getting the integer from this auto, and then the range getting as a pair from the auto as well. So as I mentioned, right, we can test all those solutions inside this USACO. I'm trying to find. Okay, so this is the first problem for mixing milk, right? So we submit the solution, then you see passing all the test cases. And then the second problem, cow signal, submit the solution, passing all the 10 test cases. And then this is the speeding ticket. So this is, even though the brute force of the first version is still able to pass this all test cases. So even though it's looping 100 times, it's not that bad, right? 100 times of looping. And then this is the second version, right? This just a little improvement. We don't have to store Betsy's speed, and then as we read through each of her speed, and we calculate the speeding. So we use one loop. Then this the last version speeding ticket problem. Okay. Before we get started, actually, I want to. Could everyone open your Visual Studio Code? I want to show you a tip, a setup, right? So there are some of those, you see some of those code, like this kind of code. Every time when we do the USACO, so pretty much the same. I wouldn't be the nice that we can just every time we started, as well as putting your name and the timestamp automatically generating all of those, right? So if there's I said a new program, say a new program. So whenever I do this, I do a control space and then getting um, a snippet, the getting all those as a template automatically generating the author and the timestamp as well as the heading with the main file reading the input and output. And then in Visual Studio Code, right, whenever you need to replace this tool, you can do a Control H on the Windows, or if you're on Mac, you do the Command H, right? You do the task, then you can replace to the actual task as the one the call signal. So you do this, it will replace all. So that's something that you can set up as a template, get your code so that you don't have to type that many. So how do we set up this called a code snippet, right? You type a control space, then it will pop up some of those snippets. There are some of those built-in, and then you can add your own snippets. So one way to do this, show you. Okay, so first do the Control P, open your Visual Studio Code, Control Shift P. So for those on Windows and for those on Mac, do Command Shift P. So you do press the Control and Shift P at the same time, will bring up this command prompt that you can type. You type, then type this, which I typed this already so that you will remember. You type a snippet, right? And then comma, configure user. Did everyone get this? So on Windows, press Control Shift P, and on Mac, press Command Shift P. Then you get to this window, and then type a snippet. Okay. So we can do the new global or do the C++. You know, let's do the global file. So select this one. Is everyone here? Select global. And then you give a name. So you type a USACO. I already have this one. So type a USACO. Then it will bring up this. It's a JSON format file like this. Okay. So let me share mine, and then you can copy and paste. That's too long. Let me cannot post it in this chat. Let me post it in the Google Classroom. So go ahead, copy this from Google Classroom, and then just change my name to your name. Change my name to your name, and then you can leave everything else the same. Then go back to the file that was open. I lost my, so the one that so go back to the one that open and then copy and paste to replace whatever that file is there. You should see it will be under your folder on the .vs code, and then it will create a code dash snippets, right? It's a USACO.co snippet like that. Should create a file like this. Has everyone done that? You save and close it, and then you can test it and see if it works. Right? Just create a new file. Right, create a new file. You already have a test okay, here. Okay. So you do once you're in that C++ file, press Control Space, or for Mac, I think you either Control Space or Command Space. I forgot that. Then it will pop up this, right? Then you type USACO. So that's the code snippet that we just did. Then we should bring up this. Does it work for everyone? Give me a thumbs up if it's working for you. If it's not working, you can do a screen share, then look at your screen. Kenny, does it work for you? Okay, so if it worked for you, so next time you start with a new USACO problem, just say open the file, then the control space, then type USACO, then you get this starting template, right? So that you don't have to repeatedly type the same include and then the main function, everything. Yeah. So for those that old problem, they are using the file. We are using this, but in the recent USACO, they already changed this. So they don't need to use this file anymore. Just do the standard input, standard output. Then, if that's the case, you don't need this. Just do a C in and C out, right? Just do a C in and C out, reading the input and output. Okay, so that's for this. Let's just quickly gets introduced today's topic, then we can take a break. So um, there is a type of USACO problem. They uh, not dealing with some geometry problem, or even simple geometry problem. They're more dealing with square or rectangle geometry. So with the shape, they give you the coordinates of those square or rectangle, then do some calculation based on those coordinates. Right. One type of typical example is give you the coordinate and then two rectangle coordinate, and then figure out this two rectangle how much they overlap with each other, right? Or sometimes you could have a three rectangle and then they could have a overlapping and then figure out the overlapping. Right? So um, for those geometry problem, right, it's easier just to use a piece of paper, do that on paper first, draw the picture, right? What kind of problem is trying to solve, and what are the um, scenarios that you need to consider, right? Which position relative to each other, with the two rectangles or three rectangle, how they. The good thing is they're all in the plane, right? They're not considered this in the 3 dimension. It's all in the 2D dimension. Everything is in 2D dimension. So you only consider X and Y coordinates and figure out those rectangle, the position relative to each other. Let's take a 10-minute break before we get into an example of this rectangle geometry problem. Okay, I hope everyone is back. So let's resume, right? So this is square rectangle geometry. It doesn't mean that you need to solve a math problem, right? The USACO's contest as everything is writing a code to solve problem. There is no math type of question that you need to answer, but it's rather you need to write code to solve the problem. So let's look at one typical rectangle geometry problem. It is a 2015 contest problem about fencing painting, right? So fence painting, so it is about this Farmer John's fence. So he's going to paint the fence, and then his cow Betsy also painted at the same time, right? The both are painting. So the problem is, so they paint this. Well, you only need to consider one-dimensional line number. So it doesn't need to figure out the up and down, but rather horizontally, right? So the interval Farmer John paints from A and B, right? Paint between the A and B, and then Betsy also paint from C and D. But sometimes they paint overlap, right? So because Betsy doesn't read what Farmer John has painted, it's just paint from C and D. So you're trying to figure out um, how much fence is actually being painted, right? So we need to figure out those overlapping. So this is a sample input. This is Farmer John's painting range from 7 to 10. So that means a painting um, what's 3, right? Then Betsy painted from 4 to 8. So Betsy painted 4, but there is one overlapping, right? So this is 3 plus 4, then subtract one overlapping. The actual painting area is 6. So that's kind of what the problem is. So it's just giving you this two sets of numbers, right? This the first set is a Farmer Johnson painting, and then the second set is Betsy's painting, and trying to figure out the overlapping. Let's see. This is shouldn't be a too hard problem. Let's everyone just open your Visual Studio Code, see if you can write this problem. So start with the snippet code that you have set up on Visual Studio Code. So you just need to read through those 4 numbers and then output 1 number. So they already determined this is A and B, and then B is greater than A, and then this is C and D is greater than C. Okay? And those A, B, C, D, they are in the range from 0 to 100. So the first part is reading those 4 numbers. Then the second part, figure out Farmer John's painting and the length, and then Betsy's painting length, then figure out the overlapping. So how do we calculate the overlap? Oh, it could be overlapped like this. It could also overlap A and B is like this, right? Or they can completely overlap. Or the C and D is longer. So if you notice a pattern, right, on the overlapping, right, we want to, for this situation, we want to find out from here to here. This is the overlapping, right? So it's a compare B and D and then C and A. And even if this situation like this is also B and D, A and C, right? And B and D, and then C and A. So we want to see the to the left, which is smaller of between B and D, with the B and D, the smaller one. And then on this side, we want to have a larger one. So A and C, the larger one, and the difference. So the overlapping essentially then is minimum of B and D, subtract maximum of A and C. So that's the formula that you figure out whether they are overlapped or not. And you need to make sure that this not division, this subtraction is a positive, right? Compare this difference with 0. If it's less than 0, that means no overlapping. Right? So if a situation there is no overlapping, so there's A and B, C and D. So you compare the minimum of a B and D, which is here, then the maximum A and C, which is here. This subtract that, so this is getting the negative, which means they have no overlapping. So with this formula, now hopefully you can write the code. If anyone finished the code, if you would like to share your code, anyone would like to share? Okay, if nobody would like to share, I'm gonna share my code. So you start with those snippets, reading the paint in and out, right? F in and F out, define those variables. Then we read through A, B, C, D. Then this is the area they initially without consider overlapping. And this is the intersection. So it is the minimum of E and D, subtract the maximum of A and C, and then we do a max of that difference with 0. So that if it's negative, then we're getting the 0. Then that's the intersection, then the total we subtract them in the output. Right. Once you figure out this formula, then the rest should be very simple. Right? If you cannot figure out this formula, you can right. One thing we said, just like what we did with the speeding tickets, right? You can just putting everything there and then check um, each coordinate. Put just a few every coordinate. Since this is not a big number, they said for this A, B, and C, they are all less than or equal to 100 from 0 to 100. So you can just do 100, right? They said 100. Yeah, it's 100. So you can just do 100, building the 100, and then just from the range they're painting, you start with those unpainted, so from 0 to 100, and you paint then paint by Farmer John, then paint by Betsy. So it's okay. They paint the overlap. Then you just count those number of elements being painted. So this is just using that array, right? You first set this 100 points. So we since they are inclusive, so there are 101, right? They're including from 0 to 100. So there are 101 data points that we need to consider. So we set this 101 from 0 to 100 inclusively. So then you set this a vector, 101 element of vector. Then this is Farmer John's paint. Well, first of all, everyone remember how we initialize with this one version to initialization of a vector. So this is a Boolean vector, whether it's painted or not. All right, there's 101 data point. We set it to false. Those are not painted. So this is using that constructor of this vector. You see this how many elements of this vector, what's the initial value, right? False. We set this how we initialize it. Then just from A and B, between A and B for Farmer John's painted, we set this painted to be true. Then for Betsy, it's C and D also true. Then we just looping through this 101 data point, 101 data point. This is each data point. If it is painted, if this is true, then we just count the total. We start from 0. We just count how many of them, right? So this is being double painted, doesn't matter, right? We're just using a true and false. If it's already true, you paint it again, still true. So that's one simple way if you cannot figure out that formula. So this is one simple way. So you should always, for this kind of problem, is not a big number. You should always have this in your back pocket, right? When you couldn't figure out most efficient way to solve the problem, start with this simple solution, right? So just feel that so whenever this needed, initialize, right? You paint it once, paint it twice, and then just inspect every position, whether it's painted or not. Just count it. Okay. So, but if you figure out this formula, so just one formula, there is no looping, so that's the most efficient. But remember this formula though, for the one-dimensional problem, when that's how we can calculate the overlapping. Okay. Okay, let's look at two-dimensional problem. Hey, so this is a 2017 USACO problem, December. So December is the first contest, right? The problem one, that means it's the first problem. It should be the easiest problem. So that will be something that when you first, when the December contest started, you expect something in this level of difficulty for the first problem. Okay, so so this is a very typical USACO problem. They give a lot of background information, very long description, so you just have to read through it. Right? But for this problem, essentially just this Betsy, the cow, look out the window. There is two billboards. One billboard, say there's two position of the billboard from Betsy's point of view, right? So those are the two corners. So two corners, the coordinates. One is on the lower left, right? The lower left. So from the bottom, just like you keep track, this is diagonal. So this lower left right here versus upper right, right? So that means from the smallest x and y, and then to the larger x and y. If we're starting this, treat this as 0, 0, that's the corner that the upper right, right? So this given this two corner to indicate to the coordinate of a rectangular billboard, right? So there are two billboards, and there is also a truck, the park between this two billboard. Well, first of all, there's a two billboard from the window that Betsy was looking at. Those billboard, there is no overlapping of between those two billboards. All right. So if you look, if we draw a picture, right? So it just from Betsy's point of view, right? So this is x1, y1, then this is x2, y2, right? Then another billboard also has x1, y1, x2, y2. So she is looking at this two billboard. Then one day there is a truck parked in front of the window that blocking some view of Betsy's view of the billboard. So it said this truck also give you the coordinate of this two corner. So now with this three rectangles coordinate is asking you how much area that Betsy can still see of this two billboards, right? So you just need to figure out whether this truck is blocking any part of one billboard or blocking two billboards or not blocking at all. So again, it gives you the range of this coordinate from, so it's not necessarily to be positive, right? It could be negative from negative 1,000 to positive 1,000. So how do we solve this two-dimensional problem? In this in this sample problem, right? Give the coordinate. So this is 1 and 2, and this is 3 and 5. And then another one is, so it is 6 and 0. So somewhere lower. So this is 6 and 0. And then this is 10 and 4. Right. Then the truck is parking 2 and 1. So so 2, so it's to the right of this corner 2. And then 8 and 3. Something like this, all right, blocking part of it. So how do we solve this problem? This two-dimensional overlapping is a little complicated. Right, first we can consider one billboard at a time, right? So just consider one billboard with this truck, whether it's overlapping with this truck. And once we figure out the area, the billboard being blocked by this truck, then we subtract that area, and then consider the second billboard and how much area is being blocked by this truck. But those are just an example. We have to consider all kind of scenario, right? If you consider two rectangle, whether they could say this is 1, this is 2, and so 2 is one of the corner is inside 1. Then it could be also overlapping like this, right? So instead of the upper left corner, it could be the lower left corner, like this, overlapping. Okay? And then So you need to consider all four corners that one of the corner is inside this rectangle. And it could be like this, right? So this is 2, this is 1, and it could be like this, right? So this is 2, this is 1. So there's a four corner. One of the corner is inside rectangle 1. And then you can, by symmetric, right? There can be the swap, right? So that it could be one of the four corners of rectangle 1 is inside rectangle 2, right? So but this should be, if you consider right, when they're overlapping, they are similarly, just the rectangle 1 corner is inside the rectangle. This is a lower right corner. This is a rectangle 1. So if you consider from rectangle 1's perspective, this upper right is inside rectangle 2. And for rectangle 1, this lower left inside rectangle 2, right? So those four positions, but there are other positions as well, right? It could be that one is completely inside another. Running out of space. So it could be one inside another. Right. It could be don't know which one is bigger, right? It could be this case. It could also be the 2 inside 1, right? But there are other situations as well. What if none of the corner they're inside? It could be like this, right? So if you just checking corner, the corner they are all outside the rectangle. It doesn't. The corner doesn't. But the edge is between those two. They are overlapping, and it could be. So if this is 1, this is 2, and then you can flip around as well, right? So this could be 1, and then this could be 2. So how do we compute those overlapping? So one way to evaluate all of those scenarios, right? To keep track the intersection. And there is just like one-dimensional problem. We can do this brute force and just build everything, right? There's a 3 rectangle, right? Is 2,000, right? It's between negative 1,000 to positive 2,000. So there are just a 2,000 by 2,000 rectangle, right? So just a 2,000 by 2,000 2-dimension. We could just fill this entire giant 2,000 by 2,000, initialize them to be 0. Then we fill the first rectangle as 1, then fill another rectangle as 1. Then when we have this truck, then put all those coordinates occupy the truck as 0. Then the remaining, the 1, then it will be the one that with 1 that will fill with the 2 billboard. We just count how many 1, then that will be the solution. So that's if we cannot figure out all kind of scenario overlapping, that's more the brute force approach. You just fill this entire 2,000 by 2,000 matrix, right? Fill them, initialize to false first, fill those area, those data point for the first billboard to be true, fill the second billboard to be true, then fill those coordinate in the truck that to be false, then count the area that is true. For this USACO's problem, even you use this brute force approach, this will pass all the test cases as well. Right? So we can actually look at the code if we use this approach. Right. First of all, when you test your code, right, you should create a sample input in your local file, like just the one in the problem in your sample input, you just copy like this, and then this so you should expect when you run the code, create an output like this, matching the expected output, right? So the first problem, the first version, so it's the approach we just using this brute force approach, setting this 2000 by 2000, this max position, right? Setting this matrix, whether it's a Boolean matrix, they are visible or not. So this is using, since we are using this dynamic matrix, not using vector. For this, there is no good way. It's not like the vector that we can set the dimension and then fill the value. So we have to use a C function called a main set. So it's called a memory set to initialize. So giving the starting address, when you define an array, right, whether it's one dimension or two dimension, the name of the array, it is the starting memory address, right? And then what's the initial value? And then how many, the last position that you want to fill. Starting from here, you set the memory to be this false, and then how many positions, right, you want to set, which we set 2000 by 2000, right? But it also for how many byte. This is for each byte. So the byte, it is based on this Boolean. So the size of this Boolean variable, it tells you how many bytes of memory that you have allocated for this each element. So we multiply the size of. So we use this size of. So this is very often when you're dealing with memory using the size of. And that this approach is more of the C language type of approach. Probably for C++, you can using the std z field. So you can look up the z field function. There is something similar like this, a main set, but it's a z field is going through a loop that fill each address with the initial value. So the Z field is not as efficient as a main set, but that probably Z field is the more of the native C++ way to initialize a vector. But we could use a two-dimensional vector, the standard, those standard template vector, then we can use those initialization approach. That is another approach, right? Okay, once we initialize this 2000 by 2000 matrix to be false, right? Then we just read the first billboard. This is first coordinates, the first billboard. But it's put the outside this loop. Yeah. But those coordinates, we're going to reuse those coordinates for the billboard as well as two billboard and the truck's position, right? You read those four coordinates, and then right now it is shifting this to the center. So this remember this is 2000 divided by 2, so you just shift this position to be the center, so that because in case that we won't get out of bound, right? If in a situation like in a situation, if this is your 0, 0, this is 2000 and 2000 corner, right? If you are in a situation on the edge here, then they give you the rectangle to go outside this 2000 by 2000. So we can shift this coordinate with the center, which is 1000, right? We can just shift here so that entire rectangle is within this view of 2000. So that's what that code is, just a shift. Just shift all the coordinate plus this center position. Then we set this first rectangle for each rectangle, right? The first two, right? When we're doing this 3 times, right? 2 for the billboard and the third loop for the truck. So the first 2 loops, then we want to set this to be true. This visible area that occupied by the billboard, the visible to be true. Then when it is not the first 2, then else we set it, the truck's position, then set it to be false, right? So between the x and 1, we just the area, the rectangle, and then the y between the y1 and y2, the area, just to fill them with this true value, right? Just to fill this rectangle's area with the true. If it's for those 2 billboard, and then for the truck, we just fill that area with a false, right? Then if they are overlapping, this will override the value of that true value, right? This is since we do this later, right? We first do those 2 billboard first, then we do the truck. So this third iteration should be for the truck, then it can override if they are overlapping. Then once we've done this, then just count this is giant 2000 by 2000 2 loops, right? This is 2 loop, and we just count this area. Well, probably rather than, so this is counting the true. Remember this is visible, the matrix is true and false, right? When you add it into an integer, it's converted into 0 and 1. So this is the work. You could also do this too, right? You do if this is true, you could do this. If it's true, then you do increment, right? You can do this, right? If you don't want to do the Boolean to integer conversion, probably this is better just to do it like that, right? If it's true, then there's the area that is still visible to the billboard, then you count those areas. And once you're done with this 2 loop, then that should be your answer. So any question on this first approach, right? So this is approach is not very efficient, but it works, right? And as long as you can pass the USACO's grading within the time, then it doesn't matter, right? As long as you can pass all the 10 test cases. And in USACO, right, it doesn't give you any extra credit whether you do it faster or smaller, as long as you can solve the problem within the time window. nobody actually looking at your code. Everything is created by the machine. As long as your code can solve the problem within the time window allowed, then you're getting all the credits, right? So you should, even though this is not efficient, you should again put this method as your back pocket, right? If you struggle with like counting the overlapping, right? Use this brute force approach. Okay, let's look at one counting overlapping. So the first attempt, right? We just go through those scenarios that we draw on the paper, right? There's a 4 scenario that can overlapping as well as the other uh, the other 4, right? There's to be a total of 8 scenario. Um, so um, so we create a class called rectangle. Rectangle class with this 4 coordinates for teacher, and then initialize set those. Remember, this is a function with the class name is a constructor. This doesn't have any argument, then it's a default constructor. And then another constructor, you can pass some value as an argument. Then you can set those value to that, right? Then you can define some method within this class. Maybe if we initialize like this, we need to have a method to update those x1, x2 coordinates, right? Right. So this is just update the coordinate. And then once you have all those coordinates, you can get the width and the height as well as the area, right? So the width is just x2 minus x1. The height is y2 minus y1. And then the area is just the product of the width and the height. So you can define this rectangle. And then let's ignore the overlapping first, right? We the first billboard, right? So this is for each, so the 4 coordinate. We just doing a loop and using an array of 4 elements to read those 4 coordinates. Read those 4 coordinates in this loop. Then you pass those 4 coordinates to this rectangles. So we creating the 3 rectangles instance of this rectangle class, right? 3 instances, right? 2 for the billboard, 1 for the truck. Right? So you do this 3 times for 1 for each rectangle. You update the coordinate of this class. So that's for the reading. Right? So just if we can figure out, right? So we already have a method to get area. That the first rectangle get area, right? And then the second rectangle get areas, add them up. That's the visible area. And then if we have this function called overlapping area between 2 rectangle, right? The first billboard, and this is the truck, right? Rectangle 2, which is the 3rd rectangle, is the truck. So this is the truck and the first billboard. This is the truck and then the second billboard. If we have this overlapping area, just subtract and then we are done, right? So this the first part reading is to be easy, right? And then this part also easy. So the only thing that complicated is how to calculate this overlapping area. Once we have all the coordinates, was this a 2 rectangle, how do we figure out the overlapping area? So that function probably is the most difficult one, how to write that function. And so we look at this overlapping area, right? This rectangle 1 and rectangle 2. We first check this is x1 and y1. This is the first rectangle's lower left corner, right? X1 and Y1 is the lower left corner. We compare this corner, whether it is in this rectangle too. So we create a function, whether this corner, it is in that rectangle. So how do we check whether a corner or a data point is inside, right? This is a data point, X and Y. How do we check whether their X and Y is in a rectangle, right? Then it is this X has to be in the rectangle and the Y also in the rectangle. And then how do we check the X? X is, right? So the X has to be greater than or equal to the smallest X and less than or equal to the larger x2, right? So it has to be within this range. X then will be in this rectangle. Or y in the rectangle is similarly, y has to be greater than equal to the smaller one and less than equal to the bigger one. So this is the x in the rectangle, y in the rectangle. When both x and y coordinate are in the rectangle, then this coordinate, it is indeed inside the rectangle. So far, so good. Okay. So if this corner is in this rectangle, how do we calculate the area, right? So this is a situation, I think we are checking and get the blank page. But the first scenario, right? This is the billboard. So billboard is our rectangle 2 versus the truck is our rectangle 1. So the first thing is checking the lower right corner of the truck. This corner is inside the billboard. If it's inside, then we calculate this overlapping area, right? So then we use this X, this position, subtract this corner's X, then multiply this Y, subtract this position's Y. So getting that area. So we use the rectangles x2, subtract the rectangle 1's x1. And we also need to check the minimum of this 2 rectangle, right? The width 1, width 2, those are 2 rectangles width. So that in case that it could be the situation that are completely inside, right? It could be a situation they are completely inside. We are just checking a corner. It could be this situation, right? So if you subtract, but that's not the overlapping, right? This is the minimum of to here or to here. So that's why you put in the minimum of the 2 rectangles width in that difference as well. And then for the height, similarly, the y1 minus y2 and the height, the minimum of them. So you do this for each of those four corners situation. That's all those four corners. And then you can flip around, right? You can also then you could be the rectangle. So we're checking each of the four corner. Rectangle 1 is inside the rectangle 2. I guess the other four we don't need to check. They are a little redundant. And then the other situation, it could be they completely block, right? The truck is bigger than the billboard. The situation, this rectangle that it is. So the rectangle 2 is a billboard. So the both corners, the lower, this is the one on the lower left corner inside the truck, and this is upper right corner also inside this truck. Then is in this situation, then it's a completely blocked. That means we have to subtract the entire billboard. So rectangle 2 is the billboard, right? Just to get the area, return the area, the overlapping area completely blocked. Okay. And then this last two situations are those they overlapping like a cross, right? You cannot just checking the corner anymore, right? It's checking whether this X is inside, and then also the Y is inside. We're just checking the X and Y, and then X and Y inside the rectangle, and you can calculate the overlapping area. So it's a lot of scenario to consider. So this if it's submitted to the USACO website, so it can solve the problem efficiently. But this logic, right? It is, if you look at it, then certainly can simplify this complicated logic, right? So it's very similar to the, so we create another version. This is right, this overlapping area. We can simplify just two line of code. So just remember, just like what we do with the one-dimensional problem, right? One-dimensional overlapping, then we do the X overlapping. So the minimum of the two, so you can, when you compare the rectangle, so the larger one, the minimum, the larger taking the minimum, and then smaller one taking the maximum, then subtract the difference between the two, the larger and then small. So that's the one-dimensional overlapping. So that's why you want to remember the formula for the one-dimensional overlap. So in this two-dimensional problem, we use the one-dimensional overlapping formula, applied it twice, right? This is the X overlapping, and then this is the Y overlapping. And then the area, we just multiply this X overlapping and Y overlapping is the area they're overlapping. To see, compared to the version 2, this is so complicated logic. Once you figure out this formula, it's greatly simplified. Right? The rest is they are identical, right? We use this rectangle class, right, with the coordinate, getting the area, we're getting the area, and then figure out this truck overlapping with billboard 1, truck overlapping with billboard 2, and just this overlapping area subtract from that. Okay, any questions on today's class? So some of you I know have not submit your homework. This is USACO's problem is all about practice and practice. If you don't practice in your homework, not going to help you much. Right? I want to emphasize that trying to complete the homework and then create an account, submit your solution to the USACO's problem thing. For now, we only use those online problems that you can verify your answer. I think those are 3 or 4 sources. One is from the USACO's website and the train the website. And then sometimes we also do the code force and then the CSES website. Right. So all those, I include the link of the source. So you can go ahead and click the link of the source and then submit your solution to verify your solution that pass all the test cases. Okay. Right. Thank you, everyone. We'll see you next week.